Finding a line tangent to a parabola. So if we have a parabola, there's another important concept that we need to find is how to find a tangent line. A tangent line is something that just barely nicks a point and continues on, just barely touching it without crossing through. If it crossed through, it would become what's called a secant line. Like a secant line would be something that cuts through this way. But if it just barely touches this point and moves on, and the parabola curves and it only touches one spot, that's a tangent. The way to find a tangent is you're going to take that point and measure the distance to the focus, and then measure the same distance along the axis of symmetry. And so once you find that second point, they call it L, the line that connects P and L will be your tangent line. So let's look at how we do that. Here it says, write an equation for the line tangent to y equals x squared minus 2 at 2, 2. So we have a parabola, and this is in the general form that we learned from like algebra 1, algebra 2, which is just a parabola facing up, shifted down 2 units. So here it is. Now, and we want to find the tangent line at this point, 2, 2, which is right 2, up 2. To do so, we first need to find the focus. So I'm going to get this in the form that we've been using today, the standard form. Put the squared terms on the left. So when it goes left, it would be negative x squared. And then I'll put the single terms on the right, which is y, negative y, minus 2. Now, since everything's negative, I'm just going to multiply everything by negative 1. So I have the equation x squared equals y plus 2. To give myself a focus, I'm going to put parentheses here and factor out the 1. And now I know that this is my 4p here. So 4p equals 1, which means p equals 1/4 or 0.25. My focus is going to be 0.25 units up since it's next to the y, and it's up since it's positive as well from the vertex. So where was the vertex? The vertex is just simply shifted down 2. It's not shifted left or right. It's just down 2. So I'll write this out here. The vertex was 0, negative 2. My focus, I would take this and combine it with the y. So it would be at 0, when I combine negative 2 and 0.25, I get negative 1.75. There's my focus. So that's the first point. Now that I know my focus, what I'm actually going to do, and they have these so close, this parabola actually should be hitting here. It's kind of a bad drawing. They connected both. The line is in the right spot. This is the focus here. We now need to find the distance between these two. So we use the distance formula. This is on the formula chart. Right here. It's a lot like the Pythagorean theorem. So let's come back over. And so to find our distance between this point here, we'll call this point P, where they have it point C, and the focus, which is here, the focus, we're going to do the distance formula. So the distance will equal the square root of x2. We'll just call this point here, the 2, 2. We'll call this x2 and y2. So you take your x2, and according to the formula, you subtract x1, which x2 is 2. You subtract x1, which this is going to be our x1 and our y1. So I subtract 0 and square it. Then I add that to my y2, which is 2, minus this negative, negative 1.75. And I'll square that. Now, to simplify, this becomes 2 squared, which is 4, plus this here, those add, and it will be 3.75 squared. Let's put that in there, 3.75 squared. Now I'm just going to go to the calculator and find out what that is. So the square root of 4 plus 3.75 squared is 4.25. So all that equals 4.25. Now I know my distance. So what does that tell me? If I have this as 4.25, I need to find this point, which is 4.25 down. So this next point here, they have it as A. On the previous slide, it was L. What you do is you go to your focus and you subtract 4.25 more because we need to go the opposite direction. So we're going down. the axis of symmetry. So when I take my y, 1.75, and I subtract that distance, 4.25, I get, these are both negative, so they combine together, and it gives me -6. So that point, really, I was from here, the focus. You subtract this from the y, you get the value 0, -6. That's this point there. That is 0, -6. That's a point. There's my other point. Now I know that my tangent line is going to be going through from this one through this one. And so all I have to do for my tangent line is now use the slope formula. So this is a line. It's going to be y equals mx plus b. And to find the slope, m, you do rise over run. So m is the rise, which we could count from 6 all the way up to 2. That's up 8 units, up 8. Or you could also do 2, the y2 minus y1, which is 2 minus -6, over your run, which is 2 minus 0. So it's rise, which gives us a total, when we turn this to positive here, of 8 divided by 2, which is 4. So I know my tangent line will be y equals 4x plus b. And then to find the b, you can look on here and see that it hits at -6. But if it was a problem, so since we know it's going to be -6, I'll go ahead and write my answer. We know it's 4x minus 6. But let's say that if they could not see where it's crossing the y-axis, what you would do, is we would plug in any other point. So you would say, oh, I have an x and y at 2, 2. And the way you would solve for your b is you just say 2 equals 4. And I plug in 2 there and add it to b. So we'd say 2 equals 4 times 2 is 8 plus b. You would subtract your 8, and you would find out that b equals -6. That's how you'd solve it if you could not see the y-axis. You would find out that -6 equals b, and you plug it in. Here's one for you to try. See what you can come up with here.